morning, good afternoon, good evening, wherever I may be watching this from. This is Cornelius Luvinda. Now we are continuing on vectors, that is collinear points. Additional mathematics vectors, collinear points, examples. So we have certain the position vector. You have this question. The position vectors of P, Q, and R are 2 of vector A minus vector B, mu of vector A minus vector B, and vector A plus B respectively. Find the value of mu if PQR is a straight line. And then you state the ratio of PQ to QR. PQ to QR. So, two things to note here. We are saying PQR is a straight line. It means the points P, Q, and R, they lie along the same straight line. Another thing to note about this, they are saying they are position vectors. Position vectors are vectors that start from the origin. So this means that when representing the point P as a position vector, it is OP. The point Q, it is OQ, and the point R, it is OR. Then we'll just proceed like that. So we are saying OP is equal to 2 of vector A minus vector B, and then we have OQ, it is equal to mu of vector A minus vector B, and then the last one, but not the least, of course, OR, which is equal to vector A plus vector B. So let's use this ratio. Alright, let's form two vectors that have mu. We're trying to find the value of mu. So we have these position vectors. Now the way you should think is that form two vectors that have mu. So one vector that has mu is PQ. PQ is 1. So let me write it somewhere here. So PQ is one vector. Another vector can be QR. So just like the ratio here, it is PQQR. If we start dealing with these they don't have Q. So we'll use the position vectors very soon. But PQ and QR, these two will be very important. These are the vectors that we are going to use to find the value of mu. So in additional mathematics, you do not need to know the exact value of mu. You are finding the value of mu in this question. This symbol means mu. Alright, let's continue. PQ will be equal to PO plus OQ, which is equal to PO. It means we are going in the opposite direction of OP. It means minus 2 of vector A plus vector B, and then OQ is plus mu of vector A minus vector B, like that. And then when we reach here, we just simplify. It would be equal to minus 2 of vector A plus vector B plus mu of vector A plus minus mu of vector B. Sorry for that. And then, because the positive and negative sign, and then we'll have is equal to mu of vector A minus 2 of vector A. So you group like terms here, you expand the bracket, then you group like terms, plus B, and then you say minus mu of vector B. like that. And then here we factor out the vector A. It will be equal to mu minus 2 of vector A plus, here if we factor out the vector B, 1 minus mu of vector B. So this is the value of PQ. Upon us knowing the value of PQ, let us write PQ here. PQ is equal to mu minus 2 of vector A plus 1 minus mu of vector B. Alright, so that's our PQ here. Due to space, I'm going to be erasing. And then we have our QR. QR is equal to QO plus OR. So the way these position vectors work, just manipulate them. It's like you go from Q to O, then again you start from O, then you go to R, because we're going from Q to R, like that. Alright, so it will be equal to, now QO means we're going in the opposite direction, So you say minus here, mu of vector A minus B, like that. We put the minus sign. Then here we'll say OR is plus A plus vector A plus vector B. This will be equal to minus mu of vector A, positive, negative gives you a positive, plus mu of vector B plus vector A plus vector B. And then we group like terms together, it will be equal to A minus mu of vector A plus B plus mu of vector B. And then we factor out the vector. This will be A, vector A into vector A is 1. Vector A into mu of vector A is mu. And then we have vector A plus 1 plus mu. And then we'll have our vector B, like that. So this is your Q R. Q R is equal to 1 minus mu of vector A plus 1 plus mu of vector B. Then if we reach at this point, it means we need to now go to the question. Right, okay, we can erase this, won't be needed, just to create more space. So we have PQ and QR, and they both have mu. And these points, they lie along the same straight line. It means that PQ as a vector and QR as a vector, they are along the line PQR. They are parallel. These two vectors, they are parallel. They are collinear, rather. So they have a certain vector that is common among themselves. It means we compare PQ and QR. So just answer the normal way. You get a vector where there is Q, because Q is not having mu. You solve accordingly. Then you come up with these two. And you come up with these two. Everything having vector A, like this. Everything having vector B, like that. You put them on one side of the equation. What I mean is mu minus 2 over 1 minus mu is equal to 1 minus mu, 1 minus mu over 1 plus mu. So what have I done? Everything having vector A, I put them on one side, which is 1 mu minus 2 over 1 minus mu, then 1 minus mu here over 1 plus mu. We cross multiply at this stage. This would be mu minus 2, you multiply by 1 plus mu, like that, is equal to 1 minus mu. So it's equal to 1 minus mu, 1 minus mu. Then we just expand these brackets. It means we are saying mu plus mu squared minus 2 mu is equal to 1 minus mu. One minus mu minus mu plus mu squared. Alright, so we have simplified and we can see things that we can already cancel out. We have positive mu squared and a positive mu squared. They can cancel out since they have the same signs. And then here we can now simplify. We'll say mu minus 2 mu is equal to, before we collect like terms, let's just write it out, 1 minus mu minus mu. We collect like terms here, it would become negative 2 minus mu is equal to 1 minus 2 mu, like that. So negative 2 minus mu is equal to 1 minus 2 mu. Okay, then we group the like terms together. It would mean that negative 2 right here, the 1 goes that side, minus 1 is equal to minus 2 mu plus mu. This is negative 3, and then this one is the bigger number here, so we get its sign, negative mu. We divide by negative 1, we divide by negative 1, therefore mu is equal to 3. So mu is equal to 3, and we have answered our first question because they wanted us to find the value of mu. And then we state the ratio PQ to QR. So PQ to QR would be, we get our PQ from here, mu minus 2 of vector A plus 1 minus mu of vector B is equal to, or let's not put is equal to, let's write the symbol for ratio. The QR here, 1 minus mu of vector A, 1 plus mu of vector B, 1 plus mu of vector B, like that. Since we know what mu is 3, let's just substitute 3 wherever we see mu. So this would be 3 minus 2 of vector A plus 1 minus 3 of vector B to 1 minus 3 of A plus a 1 plus a 3 of B. We simplify this to just simply be 1 times A, which is A. Then 1 minus 3 minus 2 of vector B is equal to here minus 2 of vector A. Then we have 1 plus 3, which is 4 times B plus a 4B, like that. And then we just, this is A. And then after we reach here, we're just going to do this. Vector A minus 2 of vector B will be equal to, you factor out the negative 2, so negative 2 right there, A minus 2 of vector B. You see what I've done? So I just said negative 2, because I saw that 2 is common here, but we also want to remove the negative sign. 2 into negative 2 of vector A is positive. Negative 2 into positive 4 is negative 2, like that. Then since we have the common vector here, if we drop the vectors, right? Let me just continue with the ratio sign. So if we drop the vectors, or if we divide both sides by this, by this and this will go, this and this will go, leaving us with 1 to negative 2. So the ratio, therefore the ratio of PQ to QR is 1 to negative 2. Thank you so much for watching and staying until the end of this video. Thank you so much for the support. This has been Cornelius Lubinda, and bye bye.